Hello, we're going to carry on with our fractions work now. So our learning outcomes for this whole topic, we're getting on with those. We know the meaning of a fraction, we can represent and identify shaded fractions, and we can find a fraction of an amount. We've looked at identifying and finding equivalent fractions, although some of us have found that a bit tricky. It's okay, there'll still be time to practice that. And we've done simplifying fractions. And last lesson, we got up to this green bit here. I can convert improper fractions to mixed numbers and vice versa. And from what I've heard, most of you have done really well with the part of that we did. We only got on to changing mixed numbers to improper fractions. So we're going to do improper fractions into mixed numbers today. Okay. Then we're going on to adding and subtracting fractions, and we'll see how far we get with that and how time's looking. So our first job, as usual, is to recap where we're up to. So first of all, simplifying fractions. Well, what we learnt, remember, was that to simplify a fraction, we need to divide the top and bottom by the same amount. So if we're going to divide the top and bottom by the same amount, or the numerator and the denominator, remember we need to spot a shared times table. So we need to work out what times table you'll find 35 and 45 both in. So we'll find 35 and 45 both in the 5 times table, which we can tell by looking at them. So if we divide 35 by 5, we get 7. And if we divide 45 by 5, we get 9. So that's that fraction simplified. 35 over 45 is the same as 7 over 9. And a little bit later on in this lesson, we're going to need to practice our simplifying fractions again. So the next thing that we looked at last lesson was changing a mixed number into an improper fraction. So let's start with 4.5. So remember, 4.5 means we've got 4 whole ones and a half a one. That wasn't a very good half a one. I'm going to redraw that. Try again. That looks a bit more like a half, doesn't it? So, in our 4.5, if we imagine each of these were pizzas that were cut in half, then we've got 2 halves in that one, 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 and 1 half in that one. So altogether, we've got 2, 4, 6, 8 halves there all together, and then another one makes 9 halves. So 9 over 2. And remember the system that we used for changing a mixed number to an improper fraction was we did that times that, and then we added that to get the number on the top. The number on the bottom stays the same. Okay, so we'll just practice that very briefly just now. We'll do 5 3/4. So remember what our system is. We're going to do 4 times 5, then add 3, and we're going to put the number on the top of our fraction, and we're going to leave the bottom number of the fraction exactly the same. So we do 4 times 5 is 20, add 3 is 23, and that goes on the top. So 5 3/4 is exactly the same size as 23 over 4. So now we're just going to look at changing an improper fraction into a mixed number. So I'm going to do a drawing again of 11 halves. So remember there's 2 halves in every whole one. So that's 2, 4, 6, 8, 10, 11. So, how many whole ones have we got there? We've got 1, 2, 3, 4, 5 whole ones. And then on the end here, we've got 1 half. Oops. Okay. If we look at, tell you what I'm going to do, I'm going to skip one because quarters are easier to draw than fifths. So we're going to look at 29 quarters. So there's 4 quarters. And another 4 makes 8. Another 4 makes 12. 16. 20. 24. 28, 29. So all together there, we can see how many whole ones we've got. We've got 1, 2, 3, 4, 5, 6, 7 whole ones and 1 left over. Now, don't forget the number on the bottom of the fraction does not change when you're changing between improper fractions and mixed numbers. Okay? And we can look and see where these numbers are coming from. Okay? Do you remember when we were doing it the other way round? We worked out this times this, add that to get the number on the top. Now, don't forget that a fraction means dividing. Okay? So this means 29 divided by 4. So if you work out 29 divided by 4, you'll find there are 7 4s in 29 and 1 left over. Okay, if we look here, 11 divided by 2 is 5, remainder 1. Okay, so let's see if we can work out 17 over 5 then. So that would be 17 divided by 5. So there are 3 5s in 17 and there are 2 left over. So your answer to the divide is your whole number. The remainder is the top of the fraction and the bottom of the fraction doesn't change. It stays the same as when you started. Okay, so this way round, it depends how your brain works, but I think these are possibly a little bit easier than doing it the way round we've already looked at. Okay, I think it's easier to change from an improper fraction to a mixed number, but you may disagree. So this one, we're going to do 31 divided by 10. So if we do 31 divided by 10, you've got 3 10s in 31, haven't you? And 1 left over, and the number on the bottom doesn't change. Okay? So if we want to write down our method, we can say that we do top divided by bottom. So the answer is the whole number. The remainder is the top of the fraction. And the bottom of the fraction doesn't change. Okay, so top divided by bottom, one little more practice, we're going to do 14 over 3. So we'll follow our method here. So we're going to do top divided by bottom. 14 divided by 3. How many 3s are in 14? There are 4 3s in 14. And 4 3s are 12, so we've got a remainder 2. And the bottom of the fraction doesn't change. So 14 over 3 is exactly the same size as 4 2/3. So your first job that I want you to do today is to pause the video and try these questions. You have these on your worksheet as well, but I'll leave them on the screen here for you. So if you pause just now. I'm going to show you the answers now, so if you're not ready, quickly pause again. All right, there's your answers. So pause to check your answers. And our next job is to look at adding and subtracting fractions. Okay, this first section is really straightforward. Right, so let's think about it. If we've got a third and we add another third, what have we got? Look at the fraction altogether there. We've got 2/3, haven't we? Which makes sense, because if you've got 1/3 and 1/3, you must have 2/3 altogether. It makes sense when you say it out loud. Okay, so what do you think 1/9 add 2/9 would be? Well, ninths are just things, aren't they? They're just a size of something. So if we've got 1 of them and 2 of them, we must have 3 of them altogether. But hold on a minute. 3/9. What did we do last time that we should do with our answer here? Well, 3 and 9 are both in the 3 times table, so we should simplify 3/9. So if we divide the top and bottom by the same amount, we get 1 on the top and 3 on the bottom. Okay, right, think about sevenths now. If you've got 5 of them and you take away 3 of them, how many have you got left? Well, if you've got 5 of anything and you take away 3 of it, you've got 2 left, haven't you? So this one is 2 sevenths. Now, it's really important to notice that when you're adding and subtracting, we don't automatically just add the denominators together as well, because that doesn't make sense. It does it? If we've got 1/3 and 1/3, it has to be 2/3, doesn't it? It couldn't be 2/6, because we haven't changed the kind of things that we've got. We've just put them together. So the next one anyway. 3 elevenths and 2 elevenths. Elevenths are just things. So we've got 5 of them all together. So it's 5 elevenths. Okay. Just going to whiz through a few more of these. 4 ninths, take away 2 ninths. Or if you've got 4 or something and you take 2 away, you're going to have 2 left, aren't you? Now, I've starred these next 2 because these are ones like the one that we looked at here, where you have to simplify the answer. Now, a question won't usually tell you which ones have to be simplified and which don't. You have to work that out for yourself, okay? But we'll do that together just now. So 1/8 and 5/8. So if you've got 1 and 5, you've got 6/8. And if we look, 6 and 8 are both in the 2 times table. So if we divide top and bottom by 2, 6 divided by 2 is 3, 8 divided by 2 is 4. Okay? So 3/4 is the answer to that one. 6/8 isn't wrong, but you should make it in its simplest form. Okay? Now, the next one, 1/4, add 1/4. Well, we know we've got 2 quarters there. And that simplifies using the usual rules to 1/2. Okay? Doesn't matter how big the numbers are, we can still deal with them. We've got 3/20, add 10/20. So 3 and 10, that's 13, isn't it? So we must have 13/20 there. And then the last one of the examples, 4 elevenths, take away 3 elevenths. You've just got 1 11th left. Okay? So what I would like you to do, no surprises here, is pause the video and try these questions. So these are all adding and subtracting with the same denominator. And I'm just going to fix... Actually, I'm not going to fix. I've just spotted that the last one there doesn't say over 15. It says over 5. So actually, I'm just going to let you think about that one when you get there. Okay? So some of these, the answers will turn out to be improper fractions, but that's okay. It doesn't matter if the top's bigger than the bottom. All right, so pause the video and do these questions. Okay, I'm going to show you the answers just now. So here we go. There's the answers. So pause whilst you check your answers, and you can see some of those I've simplified them. So wherever they'll simplify, that's what I've done. Okay, so the circled ones are the ones that have been simplified. So check your answers. Well, I hope you did okay with those questions. If you didn't, remember, nip back into your lesson and ask your teacher, whether that's me or Mr. Nicholas or Mr. Crowdy, and just check again. See if you can fix what you were doing wrong. Okay, but now we need to look, what if the denominators are not the same? So we've got a few examples here where we're going to have a think about this. So, can we add 1/4 and 5/8 in our head? It's very difficult to imagine. If the denominators aren't the same, the pieces of pizza are not the same size. So it's quite difficult to put them together. So because we've already done just all that great work on adding and subtracting fractions when the denominators are the same, if we can make the denominators the same, then we're back in the position that we were for our last set of questions, and we know we can do those. So let's have a think. We're going to make the denominators the same. So what I want us to do is actually just think about the 4 and the 8. because we know we can make equivalent fractions, okay? So I want us to think, what number or do 4 and 8 both go into? Okay, so what number do 4 and 8 both go into? In other words, what number is in the 4 times table and in the 8 times table? What's the first number? Well, if we think about a 4 times table, we've got 4, 8, 12, 16 and so on. 8 times table, 8, 16, 24 and so on. So we can see that the smallest number in both lists is 8. So what we're going to do is rewrite this question so that both of these fractions are over 8. So a quarter is going to be changed into a number of eighths. 5/8, well, we haven't changed the 8, so we're not changing the 5 either. So the 5 will just stay there. So it's only the over 4 that we need to deal with. So create equivalent fractions. Remember, you multiply top and bottom by the same amount. So 4 times what is 8? 4 times 2 is 8. So because we've multiplied the denominator by 2, we've got to multiply the numerator by 2 as well. So 1 times 2 is 2. And now we've got matching denominators, and we know that 2 eighths add 5 eighths is 7 eighths, because we've just been practicing that. Okay? So the next step. This time, we need to think about making the denominators the same again in this question. So we need to think, what's the smallest number that you'll find in the 9 times table and in the 3 times table as well? Well, if you look at your 3 times table and your 9 times table, you'll find that the smallest number that's in both is 9. So we're going to make both of these fractions over 9. Okay? Now, looking at the denominators, we've not changed anything here, so we don't change anything there either. But in this case, the 3 has been multiplied to make 9. 3 times 3 is 9. So this has been multiplied by 3. So we've got to do the same to the top there. So 2 times 3 is 6. So 8 ninths, take away 6 ninths, leaves us with 2 ninths. Okay? We might not do all these as examples. Probably don't need them all. So next, we've got 2/5 add a half. So we need to find the smallest number that is in the 5 times table and in the 2 times table. So if we think about our 5 times table, it's 5, 10, 15, 20, and so on. 2 times table, 2, 4, 6, 8, 10, 12, and so on. So we can spot there, we can write them out if we need to, but we can spot that 10 is the smallest number that's in both lists. So we're going to change these to tenths. So this is the first one that we've looked at, where we have to change both fractions. Okay, so we just do it the same way though. So we look at what we've multiplied 5 by. So 5 times 2 is 10. So we've got to do 2 times 2 there. So that's 4. And then here, you've got 2 times 5 is 10. Worked out we've multiplied by 5. So we need to times the top by 5 as well. So that'll give us 5 tenths. So now we've got 4 tenths add 5 tenths equals 9 tenths. Okay. Just going to do one more example with you, and if you're okay, you can get on and do the practice questions. But if you're not sure, can you dip back into the lesson and just ask your teacher to go through a couple more examples with you? Okay, so the next one is 5/6 take away 2 ninths. So we need to find the smallest number that's in the 6 times table and in the 9 times table. So remember, 6 times table, 9 times table. Right, what's the smallest number that's appeared in both? There we go, 18. So we're going to make them both over 18. And the way that we do that is to turn 6 into 18. we've multiplied by 3, so we need to do 5 times 3 to go on the top here. So 5 3s are 15. And then, on the next one, we've got 9 times 2 is 18. So we need to do 2 times 2 is 4 on the top. So we've got 15 18ths minus 4 18ths is 11 18ths. Okay? So well done if you think you've got the hang of that just now. Like I say, if you're not sure, you could have a go at one of the practice questions that I'm about to show you. And if you don't know what you're doing or feel like you need a bit of extra practice, just nip back into your lesson and ask your teacher for some extra examples. Because here we go, I want you to pause the video now and try these questions. So these are a little bit more tricky because the denominators are different. I've just spotted that says denominators the different, means are different. Okay, so try all those ones. Pause the video whilst you do those. Right, if you're ready to see the answers, here they come. If you're not ready, pause again, quick. So there's the answers. So you pause that and check your work. You will notice that some of these have been simplified as well. Now, if you got on well with those questions, these are a little bit more tricky. So try those ones again. Pause the video. Make sure you're checking every answer you get to see if it'll simplify. Okay, I'm going to give you the answers. Right, here are the answers. So pause the video whilst you check your work. Now, I think we've done quite a lot this lesson. You've done quite a lot of work yourselves. So well done if you've kept up with that. Quick recap of where we're up to. Remember, we were halfway through this, and now we can tick that one off. Remember, we could tick all those all off anyway. We can do that now, and we've been adding and subtracting fractions with the same denominator. And then we've been on to adding and subtraction fractions with different denominators. So well done. So it will not come as a great surprise to you that next time we're going on to this section. So multiplying and dividing fractions, but then we're going to involve mixed numbers as well after we've gone over multiplying and dividing. Okay, so well done. You've done lots of work today. Remember, just tell your teacher if you're not sure about anything and they'll give you some extra help. See you later.